That artificial intelligence sticker can tell you what a laptop supports. Right. It cannot tell you whether the laptop will feel faster for your work. Behind one sticker, the task could run in the cloud, on the CPU, on the GPU, or on the NPU. The useful question is not whether the sticker exists, but whether your software can use the hardware behind it. Welcome to TechExplorers. This channel helps you decide what to use, what to buy, and what to trust without the hype. Today, we are separating supported artificial intelligence features from general laptop performance. We will answer 3 questions before you compare any artificial intelligence PC. First, where does the artificial intelligence model actually run? Second, which processor class can support that workload? Third, what can the artificial intelligence PC label never prove by itself? At the end, we will have a simple 3-step buying check that starts with your real workload. Start with a typical chatbot opened inside a web browser. A prompt normally travels through the internet to a remote data center where the large model processes it and sends an answer back. Your laptop runs the browser, calls the interface, and manages the network connection, but its NPU is not running that remote model. Adding an NPU sticker to the laptop does not move a cloud model onto the device. The log changes only when an application or feature explicitly runs its model locally. That local workload may use the CPU, GPU, or NPU, depending on what the software and hardware support. A browser, interface, or operating system features can still use local acceleration even when the main chatbot model remains remote. So identify the execution route precisely before deciding that one local accelerator matters. Think of the 3 processors as specialists that can also work together. The CPU is the general purpose coordinator and remains useful for responsive, lower latency work and broad software compatibility. It can also provide a fallback when a workload does not have a dedicated accelerator path. The GPU is designed for large amounts of parallel work, which suits many image, video, and generative artificial intelligence workloads. The NPU is designed for battery-efficient, sustained on-device inference when the application supports it. That makes an NPU relevant to supported background effects, cognition tasks, and particular Windows artificial intelligence experiences. It does not make the CPU or GPU obsolete. One application may prepare data on the CPU, process a supported model on an accelerator, and then return the result through the operating system. Another application may ignore the NPU completely because it has only a GPU path or because its model runs remotely. There is no universal winner because the model, software, workload, or target, and hardware support decide the route. Now, separate the broad artificial intelligence PC label from Microsoft's documented Copilot PC class. Microsoft currently specifies Windows 11 an NPU exceeding 40 TOPS, or at least 16 gigabytes of RAM, and at least 256 gigabytes of storage. Those requirements create a compatibility threshold for the Copilot Plus category. They do not certify the fastest CPU, the strongest graphics, the best display, widest cooling, or the longest battery life. Microsoft also notes that experiences can vary by device, region, and time. Some features can require updates or additional conditions before they become available. Eligibility therefore tells you that a machine can enter a supported feature class, not that it is automatically the best laptop for every task. Installed hardware helps only when software knows how to route supported work to it. Microsoft's current Windows artificial intelligence documentation shows some application programming interfaces running on the NPU. Selected interfaces also have GPU or CPU support, while others remain limited to particular hardware paths. This support can depend on the application version, Windows build, device, driver, and model format. If you are buying for one advertised feature, verify that exact feature instead of assuming every artificial intelligence application uses the same accelerator. Check the developer or Microsoft support table, the required Windows version, and the hardware listed for that feature. An accelerator that an application cannot address adds no benefit to that unsupported task. This is why software support can matter more to the decision than a large number printed beside the chip. Here is the practical decision tree for 3 different buyers. Most of your artificial intelligence use happens through cloud chatbots. Begin with the quality of the complete laptop. rather than the NPU number alone. CPU, memory, display, keyboard, battery, connectivity, cooling, and price still shape that browser experience. The remote model does not become faster simply because the local laptop has more NPU tops. If you specifically want documented Copilot Plus experiences, list the exact features you expect to use. Then check the machine's eligibility for the supported processor family or region and the required Windows update. If you want local creative or generative artificial intelligence applications, start with the documentation for those applications. Confirm whether each application supports the NPU, CPU, or CPU on the processor you are considering. Also check the model size, available memory, graphics requirements, storage needs, and whether the workload can run within the machine's limits. A powerful NPU cannot replace missing memory, unsupported software, or a GPU requirement. More memory or graphics power also cannot create an NPU-only Windows feature. No single component is always the most important, so start with the task and follow its documented route. This brings us to the specification myth behind 40 TOPS. TOPS describes theoretical peak accelerator throughput under defined conditions. It is not a score for web browsing, office work, gaming, battery life, display quality, cooling, memory capacity, or total product quality. Think of it as the capacity of one specialized lane, not the travel time for every journey through the entire city. The number still matters for documented Copilot Plus eligibility and for comparing supported NPU capability under matching definitions. It becomes meaningful only when the software can use that accelerator and the compared numbers describe the same kind of measurement. Start with the task, not the sticker. TechExplorers did not perform a hands-on artificial intelligence PC benchmark for this video. Conclusions come from current first-party requirements, hardware role documentation, and software support tables. Software support can change after an application, driver, or Windows update. Vendor descriptions are attributed information, not independent performance results. Total execution is also not automatically private or secure because permissions, storage, networking, and application behavior still matter. Verify current support before making a purchase for one promised feature. The decision is simple. Start with your workload, verify whether the model runs remotely or locally, and check the exact application's hardware support. Only then compare the CPU, GPU, memory, battery, display, cooling, and price of the complete laptop. Which artificial intelligence PC or NPU workload should we investigate next? Answer in the comments below. If this evidence-led approach helped, like the video, subscribe to TechExplorers, and enable the bell. Our next investigation asks whether 16 or 32 gigabytes of RAM actually changes practical local artificial intelligence work. Subscribe now, and we will test the memory question without turning another specification into hype.